Sir, so this afternoon I'm going to continue to give the problem with solution about the temperature. So sample number one and problem number one. So first, uh, a 50 grams of water at 25 degrees Celsius was mixed 100 grams of water at 90 degrees Celsius. The specific heat capacity of water is 4.184 joules grams Celsius. So the question is, what is the final temperature of the mixture? So what we are going to do first, so let's say we have the 50 grams of water, so 25 degrees, and then we gonna pour some hot water to it. So let's say the hot water is that 90 here, 90 degrees. When these two are mixed, when these two are mixed, so what will be the final temperature? So TF here. So our final temperature between 25 degrees and 90 degrees hot water. So now we add the two numbers, 25 plus 25 degrees Celsius plus 95 degrees Celsius equals divide 2 equals 57.5 average. So his question spell would be the final temperature 75.5 degrees, or between 57.5 degrees Celsius to 90 degrees Celsius. So what would you say? Now I'm asking, what would you say? Now, if the masses of these two samples are water, if would equal, then find the final temperature will be 57.1.5 degrees, but not equal. So what we are so the cold water example, we have 50 here 50 grams, then we have 50 grams, and we have 10 grams water example. So hot water example, so because we have more hot water, find the temperature is going greater than 57.5 to 90 to last 90 degrees. So since we pour this, we're gonna take the final temperature. So let's ahead go. So now take note that the heat, the QH is releases heat energy, meaning to say it's exothermic. So the sign is negative, and the second is QC. So QC, the sign is positive because this absorb heat energy. So meaning to say endothermic. So now uh, let us so we need to identify this one, which substance releasing heat energy and which substance absorb energy. So now let's use this equation. So negative QH equals Q positive QC. So negative MC delta T equals MC delta T. So now we write down here the value of M, negative 100, then the value of C 4.184, then the value of equals the negative 90. So this negative 90 is the temperature. So now our final temperature is unknown here. This is unknown. So now equals to 50. Then 50 times 4. Then the value of our C equals 4.184. this one, and then the delta change time T is 25 degrees Celsius here. So now what we are going to do is to write down here negative 100, then TF plus 900 minus 50, TF minus 1250, 1250. So now let's add. So negative, but before that we are going to cancel this one, positive 100, negative 100 cancel, then 1250 cancel, and also this one. Now we are going to add. So 900 plus 1250. So this one, the other 10,250. So equals this one. So plus 50 plus 100. The answer is 150. So now our final temperature is unknown. So now we are going to divide. So 10,250 divided by 150. So the result is 68.3 degrees Celsius. So now let's say this one. So this temperature is close to 90 degrees of hot water. So now our final temperature, according to the problem, what is the final temperature of this mixture? So the final temperature of this mixture is 68.3 degrees Celsius. So that's all. That is the first sample of my problem in temperature.